Question 6 asks you to explain why a raindrop falling vertically through air reaches a constant velocity. Now there's 4 marks available for that, so obviously it's to do with air resistance, but you're not going to get 4 marks just for saying air resistance. So you've got to show that you understand the effect of air resistance. For instance, you might mention what happens to air resistance as the drop falls and speeds up, and why that effect causes it to reach a constant velocity. If you use words like equilibrium, you're going to show your understanding there. Right, part B, or the first part of part B, calculating the kinetic energy. We've got enough data there to be able to calculate that, so don't need any hints with that. B part 2, calculate the work done on the raindrop as it falls through a vertical distance of 4.5 metres. Now, I did actually check the mark scheme for this, which was on Caboodle, because I wasn't quite sure what it wanted. And that's not because of me being unsure, it's because of the question not being clear. Hopefully you know that forces do work, and in this question, hopefully you realise that there's more than one force acting on the raindrop. So therefore, more than one of those forces will do work. I mean, check the mark scheme, I see that what they're really wanting is the work done by the gravitational force which acts on the raindrop, in other words, by the raindrop's weight. The question itself isn't really all that clear, but that's what it's looking for. So if you know the definition of work, how to calculate work, the force that you're using is the weight of the raindrop. So far the air's been still, but we get to part C, it says the raindrop falls through air in which a horizontal wind is blowing. And it gives the velocity of the wind as 1.4 metres per second. Use a scale diagram or calculation to determine the magnitude and direction of the resultant velocity of the raindrop. So what's the velocities? The raindrop's got a vertical velocity of 1.8 metres per second. The wind's got a horizontal velocity of 1.4 metres per second. So we can add together the vector arrows for those two things and we find the resultant velocity. Remember, these vector arrows are velocities, so we're not saying that it ever does go down and then go sideways, we're saying that all the time it's going both down and sideways. So that resultant arrow gives the direction that it moves in. So you're asked to use either scale drawing or calculation to find the magnitude of that and also the direction. So the direction, I would say it was so many degrees away from the vertical. So I'd find that angle. So that's 1.8 metres per second and 1.4 metres per second. So your calculations or your scale drawing. Question 7 is about a wind turbine, and it tells you how to calculate the volume of air passing through the blades each second. Consider it to be a cylinder of radius equal to the length of the blade. The way we visualise this, if I sort of draw like a semi-sideways on view of the blades, then we picture that the air that comes through takes the shape of a cylinder. We can work out the cross-sectional area of the cylinder because we know the radius of the blades and the length of the cylinder. Well, if we're trying to work out the volume of air that comes through in 1 second, we imagine the column of air that comes through in each second. That length will be however far the air moves in a second. And of course there's a special name given for how far something moves in a second. It's called its speed. So it asks us to show that the volume of air passing through is 2.3 times 10 to the 4 cubic metres per second. Remember, whenever you get a question that asks you to show something, you shouldn't start with that answer. You should just start with your equations, work it out, get an answer, and the answer you get should be that. Sometimes people get really desperate and try blagging things by starting with the answer and working backwards. Never a good idea if you can possibly avoid it. Second part, calculate the mass of air that passes through the blades each second. Well, you know the volume, you know the density, so if you know the simple relationship between volume and density, you should be able to find the mass. Third part, calculate the kinetic energy of the air reaching the blades each second. Well, if you know the formula for kinetic energy, if you don't know it's on the data sheet, but you really ought to know it, it's got mass in it and it's got velocity. Now here, we're asked for the kinetic energy of the air per second, which is a good job really, because of course in the previous question the mass that we've calculated was the mass per second. So if you use the mass per second, you put that in the formula that has mass when trying to find kinetic energy, then what you've found is the kinetic energy per second. The last part, assuming that the power output of the turbine is proportional to the kinetic energy of the air reaching the blades per second, discuss the effect on the power output if the wind speed decreased by half. If the wind's blowing half as fast, would the wind turbine give half as much power? Well, if you think how we calculate the kinetic energy, what role did the wind speed play? We use the wind speed to calculate the kinetic energy here, and of course it wasn't just V that was in the formula, it was V squared. And if V halves, V squared doesn't halve. V squared changes in a different way. But when we calculated the mass, we used the answer up here, and we'd already had to use the speed up here to find the volume, to find the mass. So the speed comes into the equation again. So if the wind speed decreases by half, it's going to have a much bigger effect on the kinetic energy per second that reaches the turbine. We've got to work out exactly what is the factor